how gas volume, so how our volumes are accurate at various temperatures when we're using our pulmonary function lab. So we use Boyle's law to be able to convert our ATPS. So when we're at ambient temperature, we're converting all of those values to body temperature. So that's our primary source of conversion. But we also use Charles' law to help us make sure that our gas volumes are always going to be accurate at different temperatures, because that's going to be a standard, right? It could be that the gas, in the tank that day is at this temperature versus this day, it's at this temperature. So it's just ensuring that the gas volumes are all going to be accurate at different temperatures. Okay, our next one is Gay-Lussac's law. All right, so I'm going to erase this. And who can tell me what's constant in Gay-Lussac's law? Volume. You forgot. Yeah, volume.
How much volume is that?
Yeah.
Oh, I like that. There you go. All right. Okay. So here again, now we've got a pressure on top. Remember, temperature again always goes on bottom. So now we've got a new pressure over a new temperature. And again, they're a direct relationship. So if temperature goes up, pressure goes up. If pressure goes down, temperature goes down. So they move the same direction. Both of those variables move the same direction, no matter what you do with them. I think I've got an example here. I've got some pressure in an ice bath and then hot. Yeah. So here's your showing it in an ice bath, and you're seeing that now the gas molecules are slowing down at 1 atmosphere, and then if you put them in boiling water, and what is happening here? Pressure. What's going on with this thing? Is it losing something? Is it? I don't know what's happening with this. It seemed like it was a really good diagram. Is there more to it? No. Temperature. I don't know what this is telling me.
Boiling water.
And then, but the pressure is different. The pressure, what's happening? Oh, well wait, but the volume is the same, right? I don't know. Scratch that. I don't know what's going on. It's fine. We're gonna just, well, I thought that was a really good depiction, and now I'm maybe not seeing it. But the volume, I don't know. I'm not gonna spend my time thinking about that. That's too. Did it make sense?
It says boiling water. So
Yeah.
The temperature, so the pressure is up.
Right, and the pressure went, but what about the volume? Was the volume just the same? Is that what, but it has to be the volume is the same. The volume is constant. So maybe it is the volume.
Yeah, the volume didn't change.
Maybe that's what it was saying. The volume of the molecules didn't change.
The volume of the ice bath, maybe?
No, neither one of them changed.
Has to be the volume inside didn't change. But the temperature went up. I don't know. Hurts my brain.
Curve question.
All right, okay, so let's do some practice using Gay-Lussac's law. Okay, so we have a starting pressure of 2,000 psi, and we have a starting temperature of 300 Kelvin. Now, don't let the units of measure, don't let them bother you, right? It doesn't matter what units of measure as far as, because this could be PSI, right? This could be millimeters of mercury. As long as it's a unit of pressure measurement, it doesn't matter which one that it actually is, right? This could be Kelvin, this could be Celsius, this could be Fahrenheit. Don't get tripped up on, oh my gosh, it's Kelvin. As long as it's a unit of temperature, it doesn't matter which one it is. Okay, and then over here on our 2 side, what we're trying to find, it looks like, is the new pressure. That's where our X is gonna go, because we have a new temperature of 600 Kelvin. Okay, so we're looking for that new pressure. which is, looks like it's gonna be a PSI, right? Okay, so again, you're going to, is that 2,000 or is it two? It is, okay. I wanna make sure I didn't have too many zeros there. All right, so now you're going to cross multiply. Again, you're gonna get a huge number. That's gonna be a lot of zeros. I think they did it the other way too, so don't let that confuse you.
Can we do it that way though, if you have to do
You
it that way?
can do it that way if you want to. That's what I was saying, there's more than one way to do this, so you can do it however you'd like to. What is that gonna be, one?
It's
Gosh, is that gonna be
5
one?
5 zeros.
Right, 5 zeros, yeah. Woo,
Wish my
There we
bank
go.
account looked like that.
yeah. For real. Equals 300x, so then divide that by 300.
4,000.
What did you do?
Did you
cross
cross
multiply? I did. Here I did, yes. And I just did it in my head. Because it was 1, 2, 3, 4, 5 zeros. So let's see, what is that?
4,000.
4,000? Okay. And that's gonna be PSI. Which, okay, so if we look at it, what happened here? So our temperature went up, and so our PSI should have gone up, right? And it did, right? It went from 2,000 to 4,000. And honestly, you could have just looked at this and said, okay, my temperature doubled, and so my PSI should double. So all you really had to do was double it, right? 4,000. So we could have,
So going forward, we just do that?
you could have just done that too. There was a couple ways you could have done it, but I don't want you to rely on that because that's probably not gonna happen very often where you just see a number double, right? But this one just happened to do that. So. Okay, I think you got one more, yeah? To practice on this one? Looks like, what's happening on this one? It's almost the same, isn't it? Oh. Is it just the opposite? Oh no, it's a little bit different. I was like, is this just the opposite? It's a little different. Okay, everyone get the right answer, 1,200? Okay. So however you want to do those. And so you have, so Gay-Lussac's law is helpful in determining pressure in closed cylinders. Because again, if the temperature goes up, the pressure will go up. We were talking about that with the soda can, right? If on a hot day, that's why it's going to burst. And I just threw this in here, also why you don't. I don't know if someone in this room's done this. Throw an aerosol can in a bonfire. Did you just raise your hand?
I had my hand on my side.
I thought you was like, Sherelle. Someone has been to a party.
I accidentally did one time. I was burning boxes in my garage and there was a spray paint can in there and I didn't know. And
Oh.
it was super loud.
It was super
I thought
loud.
a gunshot
It sounds
went
like a
off.
gunshot,
Yeah,
doesn't
yeah.
it? Yeah.
I was like, what was that? My friend was like, I think there was a can in there.
There was a party and.
So it's always at a party. It starts at a
Somebody
party.
threw a beer bottle. It's just the glass, and the glass exploded and it cut a girl's face open.
Oh
Should
my
know that you
gosh.
are, yeah.
It's like Final Destination.
Mm-hmm.
I said, it always starts at a party. It was always a bunch of like football players. Usually they're like being drunk and
Rowdy.
stupid and rowdy. Yeah, and then we're gonna see what happens. I'm like, someone's about to die. Idiots and drunk babies.
Something about boys.
There is something about boys. Uh-huh, yeah. Then you add alcohol into that and, yeah, all right. Okay, what's our next slide here? We've got ideal gas law? Combined gas law. Well, it is, yeah. Okay, or AKA the ideal gas law. And so that's how you can write it out. And remember that it just explains the relationship, the very complex, often misunderstood relationship, right, between our three variables of volume, pressure, and temperature, okay? When we're trying to predict an unknown. We're trying to find the new variable often, which is why I did give back points. I just did it this morning too, so if you were all wondering about your additional point hanging out there on either a test, you saw it, okay, yeah.
I didn't say, I was like.
Well, I did, they were sitting on my desk, so I was like, oh shoot, I have to do that right now before I forget. They're gonna come at me with
Yes.
pitchforks. I know.
Especially had the right answer.
I know. Okay, all right. So now hopefully you can do your gas laws worksheet, and then we're going to try to do that, and then we're going to do some practice with this, with using them in like a Word format, right? On Wednesday. So we're going to do a little bit of practice with that. So okay, but try to do some of that on your own too. All right. Okay, let's take a quick 5-minute